Hello dear viewers, a very warm welcome to our channel. It's very good to have you here. In this video, we are going to have a look at all you need to know about the engine control unit. The engine control unit, ECU, is also called the engine control module or the powertrain control module. It is an onboard computer that manages and controls your engine core functions. Think of it as the brain of your car's engine. The core mission here is to ensure the engine runs efficiently, powerfully, and with the lowest possible emission by constantly monitoring network of sensors and adjusting the engine actuators in real time. Well, when you look at the brief history of the ECU, from 1960s to 1970s, the ECU were a simple analog device used primarily to control carburetors and later early electronic fuel injection systems to meet new emission standards. The Volkswagen Type 3 in 1968 was one of the first production cars with an ECU. In 1980s, the rise of microprocessors made ECU more powerful and commonplace. They began integrating control of fuel and ignition, leading to more efficient engine management. From 1990s to today, ECUs evolved into incredible powerful 32-bit computers. They now manage dozens of functions simultaneously, from the engine and the transmission to stability control and diagnostic. Modern high-performance cars can have over 100 million lines of code in their ECUs. Now, what are some of the core functions of the ECU? What does it really do? Well, the ECU is a master of three critical systems. The first one is the fuel management, second one is ignition timing, and the third is emission control. When we mean a fuel management, the goal here is to calculate the perfect amount of fuel and then inject that metered fuel into the cylinders. How does it work? Using data from the mass airflow sensor and the manifold absolute pressure sensor, the ECU determines how much air is entering the engine. It then commands the fuel injectors to open for a precise duration, which is called pulse width, to create the ideal air-fuel ratio. This is typically from 14.7 to 1 for normal driving. This is also known as the ideal air-fuel ratio or the stoichiometric air-fuel ratio. And then, when we consider ignition timing control, the goal here is to ignite the air-fuel mixture at the perfect moment for maximum power and efficiency. How does the ECU perform this? Using data from the crankshaft position sensor and the camshaft position sensor, it knows the exact position of the pistons. It then calculates the optimal time to send a spark, advancing or retarding the timing based on engine load, engine speed, and temperature. And there is also emission control task. The goal here is to minimize harmful exhaust emission. How does the ECU go about this? The ECU manages systems like the exhaust gas recirculation valve and the evaporative emission control system. Most importantly, it uses oxygen sensors in the exhaust to manifold the air-fuel ratio in real time. If the mixture is too rich or too lean, it makes immediate correction in a continuous feedback loop called closed-loop operation. Now, the ECU doesn't just operate in a vacuum. It is a central hub in a vast network. There are key sensors that are used as an input, and there are actuators that can perform some task. Let's focus on the sensors, for example. We have the mass airflow sensor that measures mass of air entering the engine. There is an oxygen sensor that monitors the amount of oxygen in the exhaust to determine fuel mixture. There is a crankshaft or camshaft position sensor which tells the ECU the position and speed of the engine. There is a throttle position sensor that reports how far the accelerator pedal is depressed. There is a coolant temperature sensor that monitors engine operating temperature. And we have the manifold absolute pressure sensor that measures intake manifold pressure. And we have knock sensor that detects abnormal combustion. For example, if there is pinging, if there is knocking inside the engine, all that will be reported to the ECU by the knock sensor. This will help the ECU to retard ignition timing to prevent engine damage. Now, there are actuators to be ordered by the ECU. Actuators are outputs. They are the muscles that will perform some task. Now, there are fuel injectors, for example. Fuel injectors ignition coils, and idle air control can be regarded as actuators. Fuel injectors, they precisely spray fuel into the intake manifold or cylinders. Ignition coils, they create the high voltage spark for the spark plugs, and the idle air control valve or the electronic throttle body controls engine idle speed. We also have variable valve timing solenoid, which is an actuator that controls oil flow to adjust camshaft timing for efficient engine operation and improved power. And we also have the EGR valve. This is an actuator that helps in recirculating the exhaust gas, recirculates the portion of exhaust gas back to the intake in order to reduce emission of nitrogen oxides. Now, the ECU doesn't think of itself. It follows a complex 3D digital lookup table called the map or the tune. This map is programmed by the manufacturer and contains thousands of predetermined values. Let's have an example. For example, let's have one simple ignition map. The map might say at 2500 RPM and 40% engine load, the optimal ignition timing is 20 degrees before TDC. The ECU simply cross-reference its current sensor inputs, RPM and engine load, and then executes the command from the given map. This is a very simple example showing you how the ECU actually operates. It is running based on a pre-programmed instruction set. Now, when the ECU goes bad, there are always some indications. There are symptoms. The first symptom is obviously the check engine light. The most obvious sign, the ECU, if it fails, if it has detected a fault in one of the circuits or sensors, then it will illuminate a check engine light and a diagnostic trouble code is generated. Poor performance is another symptom of a bad ECU. Stumbling, hesitation, lack of power, or rough idle could be caused by faulty ECU. Poor fuel economy can also indicate bad ECU, often due to incorrect fuel trims or faulty sensor forcing rich mixture. Engine stalling or not starting at all can also be indicative of ECU problem. The ECU may not be able to receive critical data from position sensors, for example, from crankshaft position sensor, then that will prevent the ECU from running your engine. And failed emission tests can also be indicative of common ECU-related problems. The ECU cannot bring emission systems within legal limits if there is a problem. Now, always remember, the ECU itself is a robust component and rarely fails. 90% of ECU problems are actually failed sensor, failed actuator, or wiring issue. Always diagnose the related components before condemning the ECU. Now, there are other tasks that can be done on the ECU. We call them ECU tuning. This is a remapping of the brain. This is a process of modifying the factory installed software or map and then change engine performance characteristics. There are people who do engine tuning. You can do performance tuning, which is adjusting fuel, ignition, and boost if it is a turbocharged engine. All these maps can be changed to increase horsepower and torque. There is also economy tuning. This is where ECU is made to be optimizing map for better fuel efficiency. And there are also deletions. This is removing controls from emission equipment like diesel particulate filter or exhaust gas recirculation. This is actually illegal for road use in most regions. And how do people remap the brain? How do they do ECU tuning? This is done via an OBD2 port using specialized software and hardware. The modern ECU is evolving into a more integrated domain controller, managing not just the engine, but also the transmission. That is why we sometimes call it the PCM, the powertrain control module, and interacting seamlessly with other vehicle computers for stability control, infotainment, and others as well. In the area of connected and autonomous vehicles, the ECU's role as a core decision maker for propulsion is more critical than ever. Now, the ECU itself is a sophisticated computer. Its core components include the microcontroller, the memory, the analog to digital converter, and the output drivers. The microcontroller, this is the true brain or chip. This is a specialized integrated circuit containing a processor core, which is called CPU, memory, and programmable input-output peripherals. It is designed for real-time control, not general-purpose computing. And we have memory. There are different types of memories. For example, we have the ROM, read-only memory. This stores the permanent low-level boot code. And we have the RAM, random access memory. This temporary memory for real-time calculations and sensor data. This is wiped out when the ignition is turned off. And then we have the EEPROM, the electronically erasable programmable ROM. This is where the golden maps and calibration data are stored. It is not volatile, doesn't erase when power is turned off, but it can be rewritten via specific programming procedures, via flashing and tuning. And there is an analog to digital converter. These are critically there to translate analog signals from sensors like throttle position sensor into digital numbers that the microcontroller can understand. And then we have the output drivers. These are robust power transistors that can handle the current required to actuate components like fuel injectors and ignition coils. They act as the microcontroller muscle. When you look at beyond the simple power increase, tuning is a complex engineering discipline. There are fuel maps, for example. These are not just one map, but often a primary map and various correction maps for temperature, altitude, and air density. Tuners adjust the target air-fuel ratio throughout the RPM and load range. The stoichiometric air-fuel ratio is 14.7 to 1. This is used for cruising and efficiency. There is a power enrichment ratio, which is from approximately 12.5 to 1, the rich mixture for maximum power and cooling under high load. And there is also a lean cruise, which is 15.1, 15.5 to 1 for even better highway fuel economy. So this is known to increase emission of NOx. And the ignition timing maps are there, the most dangerous part of tuning. This is advancing the ignition timing, making the spark happen earlier. This increases power and efficiency, but it is too much advanced. It can cause engine damage, it can cause engine destroying knock. And retarding, which is delaying the spark, will sacrifice engine power but protects the engine. There are also boost control procedures, turbo or supercharged controls. The ECU can control a wastegate solenoid to precisely manage turbocharger boost pressure, creating massive power gains as well. Speed density versus MAF tuning is there. As mentioned earlier, some tuners abandon the MAF sensor and tune entirely based on the manifold absolute pressure sensor. This is common in high-power modified engines where the MAF sensor becomes a restriction or can't accurately measure turbulent high-volume airflow. The ECU isn't just about performance, it is also engine's primary bodyguard. Well, it will limit the engine RPM, for example. It prevents the engine from spinning so fast it destroys itself mechanically. These are often result in valve float or throne rods if engine is made to accelerate or revolve at extremely high speed. There are often two. There is a fuel cut limiter and there is a soft cut limiter that retards ignition timing first and then go ahead reduce fuel volume. There is also boost limiting. This prevents overboosting in forced induction engines to prevent the engine. Torque management is also there. In modern automotives, the ECU will deliberately retard ignition timing or cut fuel during aggressive shift to protect the transmission from shock load. And there is also a limp mode, fail-safe mode. If the ECU detects a critical fault, it could be no signal from the major sensor, for example, it will enter into the limp mode. This uses extreme conservative default values to allow the driver to limp to a repair shop without causing further damage. Power is severely reduced. So, the modern ECU is an integral to your car's security. It works in hand with the key fob or transporter, which contains a unique digital code and a reader coil around the ignition barrel. When you insert the ignition key, the ECU challenges the key transponder. If the key does not respond with the correct code, the ECU will simply not allow the fuel injectors or ignition system to operate, making the car impossible to start. This is why replacing an ECU often requires complex repairing procedure with the car key. The ECU is a prolific data recorder as well. There are freeze frame data. When a fault code is set, the ECU saves a snapshot of all sensor data at that exact moment. It could be RPM, it could be load, it could be temperature, which is invaluable for diagnosis. There is also data logging. Using a scan tool, a technician can record live sensor data and ECU parameters. This is essential for diagnosing intermittent problems and for verifying the result of a tune. And readiness monitor is also part of a diagnostic. For emission testing, the ECU runs a series of self-tests on systems like the catalytic converters and the evaporative control system. A ready status means the test has been completed. A tuner can see if their modification have caused monitor fail. The era of dozens of isolated ECUs is ending. The automotive industry is moving towards domain controllers and centralized computing architecture. Instead of a separate ECU from the engine, transmission, and stability control, a single powerful computer like a server will manage all these functions. This allows for more complex integrated control and is cheaper to produce. AI and machine learning is also coming into picture. Future ECUs may use AI to continuously adapt to driver's style, fuel quality, and engine wear, optimizing maps in real time for the entire life of the vehicle, far beyond static factory programming. So these are some of the things that you need to know about your engine ECU. Let's summarize some of the takeaways. Well, the ECU is the brain. It's a powerful computer that makes real-time decisions to run your engine. It listens and commands. It uses data from the sensors to control and command actuators. The three main jobs: managing the fuel, managing the ignition, and controlling emission. It follows a map. Its behavior is dictated by pre-programmed software maps. It rarely fails. Most ECU-related problems are faulty sensors or wiring. It can be reprogrammable. Tuning is there. This alters maps to change performance. So, the ECU is the key shift from analog to digital, transforming physical phenomena like airflow, temperature into abstract data. The battle to control is there. Who controls the device you own? The manufacturer is in control via proprietary software, or you, the user, through the right to repair and tune. This is a battle of control regarding ECU. Who is controlling your vehicle? Is it the manufacturer or is it you, the owner? And relentless, silent quest for a squeeze every joule of energy from a drop of fuel is what is guiding ECU modifications. So there is a paradox of complexity. It makes the car more reliable and efficient than ever, yet when it fails, it becomes just a black box that can be incomprehensible without specialized tools and knowledge. Understanding the ECU is to understand the heart and soul of modern automobile. It is no longer just a mechanical device. It is a sophisticated, data-driven cyber physical system on wheels. Understanding the ECU, it will demystify much of your car's modern operation and makes you a more informed driver when something goes wrong. So these are some of the crucial things, very critical things that you need to remember and you need to know regarding the brain of your engine, the ECU, the electronic control unit. Well, dear viewers, that is all we have for you in this video regarding all of the things that you need to know about the engine control unit. If you like this video, please do smash the like button. If you are new to this channel, do consider subscribing, turn on notifications so that you will be the first to get notified whenever we come up with another video. Until then, stay safe.